Welcome to the place where we gain knowledge through the lens of creativity. I am Aaron Dworkin, and this is Artful Science. Thanks again for joining me here on Artful Science. Today's show is Bridge or Destination, Natural Gas and its Role in the Journey to a Carbon Neutral Future. And my guest is Michael Weber. Michael Weber serves as the Josey Centennial Professor in Energy Resources, is an author and professor of mechanical engineering at the University of Texas at Austin, and serves as the Chief Science and Technology Officer at ENGIE, which is a global energy and infrastructure services company. So he's not necessarily that busy. Michael, welcome to the show.
Thanks so much for having me. It's great to be part of this conversation.
Yeah, so we always love to tackle these issues that, especially from an artist perspective, we're like, we really need to learn a little more about this and how it's affecting our daily lives. So, we kind of all know about natural gas, and many of us have it coming to our homes. But let's start there and just to a little bit better understand natural gas. How much do we use? How prevalent is it now in terms of the energy that we use?
Natural gas is pretty familiar to a lot of people because you might use it to heat your home or heat the water at your home or to cook with it. So natural gas is pretty familiar to many Americans. And we like gas because it brings a lot of energy, a lot of heat in a narrow pipe. So it's a pretty dense way to move energy and to use energy. And we can use it also in industry for heat or to make chemicals, things like plastics that we might have around the house, or even clothes you wear, like polyesters and things like that. And also to make ammonia as a fertilizer. So natural gas is really important for our homes, but also very important to industry. And overall, about a third, just under a third of the energy we consume in the United States is in the form of natural gas one way or another. It's the second most popular form of energy after petroleum. Petroleum use is actually level or dropping, and natural gas use is increasing though. So natural gas use might surpass petroleum in the coming years, which is sort of interesting. So it's one of the more important forms of energy today. And the question is, will it be a part of the energy mix in the future? Because the methane that is a primary constituent of natural gas, it itself is a greenhouse gas. So if that methane leaks from pipes or from wellheads, or even if you have a loose connection at your home heater or something, that is a greenhouse gas, a very active greenhouse gas. And when you burn the methane, it forms carbon dioxide, which is also a greenhouse gas. So natural gas is really convenient. It's really cheap. It's really easy to use. It's pretty clean compared to oil or coal, but it's a greenhouse gas. And so we have to figure out, well, it's a really big part of our energy today, our energy mix today. Is it a part of our energy mix in the future?
Gotcha. So, and just trying to understand that a little bit better in terms of its impact relating to being a greenhouse gas, is there, compared to petroleum, compared to, coal, how much less of an impact does it have on the environment? Do we have a sense of that?
We do. If we think of the different fuels, if you take a hydrocarbon, which has hydrogen and carbons on it, that's things like coal and oil and even biomass like wood and natural gas. When you burn a hydrocarbon, it forms carbon dioxide as a major constituent of combustion. It's one of the main waste streams, and that is a greenhouse gas. And coal is the dirtiest of them. So coal is here, then petroleum's here, and natural gas is here. Natural gas, when combusted, is about half the carbon intensity of coal, and maybe a third less than petroleum. So natural gas is the cleanest of those three major fossil fuels. So that's the good news. It's a very clean fuel. It also has less of the other pollutants like the sulfur oxides or the nitrogen oxides, which could be a problem with coal. Those are the precursors for acid rain. So we worry about that, as well as things like soot and particulate matter. So natural gas is much cleaner than coal, which is a main competitor in the power sector. The natural gas, the methane itself, is also a greenhouse gas. So this is one of the challenges with methane, is when you burn it, it forms carbon dioxide. But if it leaks along the way with what we call fugitive emissions, or if you even vent it on purpose, that methane is a much more active greenhouse gas than the carbon dioxide. It's a couple dozen times worse. So we have to make sure the system is sort of airtight, so to speak, so there's no leaks. And then we burn it, we need to make sure we burn it efficiently and cleanly and that kind of stuff. So we like to say, like, natural gas is the prince of the fossil fuels. It's the cleanest, but if you handle it badly, it can be problematic as well.
Gotcha. And just as a little side note, if we have like a gas leak in the house or whatever, we smell that odor, which I think is actually an additive, right? So that we can detect it. Or is that the methane that we're smelling? Is that?
That's an additive. Yeah. So natural gas, for the most part, doesn't have a smell. The smell is added so that our noses can serve as leak detectors in our homes for a safety purpose. And that's like a methyl mercaptan. It's a chemical form that is similar to methane, but has a sulfur atom in it that we can smell very easily. We can smell the sulfur. So that smell is manufactured or not natural and added just for safety purposes.
Gotcha. So now when we talk about carbon neutral, right? And I'm always hearing this and obviously want to be very responsible when it comes to the environment, especially the future of our planet. So I hear carbon neutral, but I think I have to admit that I don't actually know what that means technically. So if you could just share kind of what does carbon neutral mean? And is natural gas, would that be considered carbon neutral for the future?
Natural gas, the way we do it today, absolutely is not carbon neutral. And the question is, could it become carbon neutral someday? And there are a couple of pathways it could be. Now, and the one reason why you might not know what carbon neutral means is because there are many definitions. There's no one standard definition, but I'll tell you what a more common definition of that is. When we say that the economy in the United States might be carbon neutral by 2050, that's a pretty common goal announced by, say, President Biden and different groups, including industry groups and environmental groups, say, let's go carbon neutral by 2050. That means the net carbon dioxide emissions or net greenhouse gas emissions to the atmosphere will be zero. Actually, there will be some emissions to the atmosphere, but we'll take them out of the atmosphere at the same amount. So we might reduce our carbon dioxide emissions by 80% by 2050, but there's still that 20% of emissions. But then we can go add something like direct air capture, which scrubs the atmosphere, or plant trees, or do soil carbon sequestration. We might do some different things that take CO2 out of the atmosphere to take that last 20% and put it into a product, or put it into the soil, or put it into plants, or put it into the ground. And so that means on net or on total, it would be zero. Even though there still might be some emissions, we go take them out of the atmosphere. We make a mess and then clean it up is one way to think about it. And cleaning it up takes some effort. So we want to reduce how much mess we make first and then do the cleanup next. That's carbon neutral kind of on an annual basis. However, by 2050, if we're carbon neutral, we still would have put CO2 into the atmosphere for 200 years at that point, with the Industrial Revolution, say the second one in the mid 1800s. So we still have 200 years of carbon dioxide we need to go scrub out of the atmosphere. So we need to go carbon negative at some point as well. And this is where natural gas could be interesting, because natural gas could be fabricated from the CO2 in the atmosphere. So we could take CO2 out of the atmosphere to make the gas, and then we use the gas. Or we could then burn that gas and capture the carbon and put it in the ground. We can actually make carbon negative natural gas if we make it the right way. And so the fuels today are a source of CO2, but could be a carbon sink, meaning we take CO2 out of the atmosphere. So one reason I think natural gas is interesting is it could be carbon negative in the future, which helps us not only get to carbon neutrality or carbon zero, but go carbon negative to clean up 200 years of mess.
Wow. So that's amazing. And now I could only assume that that different way of utilizing and manufacturing natural gas, or creating natural gas that we can use, that would take a lot more expense than current methods use. Is that an issue? Is there an economic factor to make
exactly
that?
Yeah, exactly. So today we take carbon out of the crust in the earth and dump it in the atmosphere. So it goes from the earth to the atmosphere. We take fossil fuel reserves of coal or oil or methane, all of which out of carbon, burn it and dump it in the atmosphere. In the future, we need to take it from the atmosphere and put it back in the ground. And those devices either are not as mature, they're sort of newer, they're more expensive. So it's certainly easier to pollute for free. Like if you don't have to pay for your pollution, that's cheaper than having to clean up after yourself. And this was true for wastewater and water pollution. We used to just dump sewage in the rivers. And then one day people said, you can't dump sewage in the rivers anymore. And people said, well, it's kind of expensive to not dump sewage in the rivers. But we said, figure it out. And they figured out how to not dump sewage in the rivers. And then we said, not only that, you have to go back and clean the rivers up even more. Well, that's going to be expensive. Figure it out. We figured out how to take that water and clean it. And we'll do the same thing with the atmosphere. Right now, we can dump waste in the atmosphere for free. And we're kind of at the point where we're saying, cut it out. You shouldn't do that anymore. And we'll also go back and say, okay, now go clean up the 200 years of mess that you left up there. So it creates some expense, but also creates opportunities for innovation. We'll figure it out. That's what we do. And so I'm pretty optimistic we'll drive down the price and we'll get used to it, and we'll have a better economy as a result.
Wow, awesome, amazing. And one thing to kind of take that further, this is what we're doing in the United States, but obviously when it comes to the environment doesn't stop at our borders. is there a sense that if the problem is not solved globally, that in the end, ultimately, just if we are only acting alone, we won't be able to benefit from the positive environmental impact we're having? Or how does that pan out?
This is a great point. So for a long time, the pollution was always local. So if you contaminated the land or the water, it was a local effect. And then even with coal plants, most of the pollution, say the soot or the ash, that kind of thing, would drift locally, or maybe with acid rain, it drifts over a couple of states. But with the carbon dioxide, it mixes uniformly around the atmosphere. So the pollution becomes a global consequence. It's not just a local effect anymore. And this becomes pretty difficult because the environmental policies that we pass to clean up the pollution in our backyard that kill our children are hard to pass, even when the evidence is obvious. But with CO2, which mixes uniformly and spreads around the world and impacts people who haven't been born yet, and when they're born, will be born halfway around the world, is a harder kind of policy thing, because we're telling Americans, clean up your act so that Bangladeshi children 100 years from now have a better opportunity for a future. And that's a hard negotiation for us to have with ourselves. And it's hard for us to do it alone. If we're the only responsible actor in the world, we won't solve the problem. And we've used this in the United States as an excuse not to take action, like, well, we can't fix it ourselves, therefore we shouldn't even try. And personally, I think that's a cop-out and kind of lazy, because the rest of the world, frankly, is kind of waiting for us, because China and India will say, well, if the rich country that provided most of the mess isn't going to do it, why should we do something? So they're waiting on us. And I think what will happen is we'll develop the technology, we'll become a responsible actor. Other countries will follow, because we'll drive down the cost for them. And we'll recognize that we all benefit, because as you clean up the CO2, you clean up the other pollutants, the mercury, the heavy metals, particulate matter, the soot, that kind of thing. And that will reduce incidences of asthma or missed work days and hospital requirements, all this kind of thing. We'll have so many economic benefits that other people will see that and want to mimic it.
Wow. Well, it definitely is extraordinary and complex. But I definitely find myself leaving our conversation optimistic about what we will be able to do and kind of the path that we're on. So I think that's good. We're unfortunately just about out of time, but I always like to ask my guests, we're here at this intersection of kind of the arts and sciences, and is there either an artistic practice that you have, or a discipline or arts that you love to enjoy and observe?
Well, I'm a part of a band family and a music family. I played piano and trumpet for many years, all the way through college marching band. I met my wife, the trombone player in the marching band, and we got married and engaged right there on the 50-yard line at the University of Texas. And our daughter's a music major, and our son's in the marching band, and our youngest son's a tuba player in the high school band. So we're a band family. I'm the worst musician of the five of us, so I try to find my creative outlet by writing as much as possible. But we have a habit in our family to write or draw or create every day. And I find that for me as an engineer, doing a little bit of creative outlet makes me a better engineer. I think the A of arts and STEM to STEAM is really critical for us engineers to do a better service to society.
Well, that is so awesome. And, we've got a lot of band going on here at the University of Michigan. So
I've heard.
Yeah, absolutely. Well, Michael Weber, thank you for helping us gain knowledge through the lens of creativity here on Artful Science.
My pleasure. Thank you for having me.